Good day, teacher everyone. For today's video, I am going to explain my code and based on the activity that has been given to us by our instructors, Sir Inoko. First, we are going to read the instruction that says create a Java program that implements tree sorting algorithm, which is the merge sort, quick sort, and heap sort. It allows the user to choose which algorithm they would like to use to sort a list, then compare the performance of each sorting algorithm by measuring the time taken from sorting. So it says demonstrate your output through a video tutorial. So since my code is very complex, and it is very too long to demonstrate each function. So that is why I am going to explain rather to you how this code works on the function of each code. So let's start from here. First of creating my name class, my name, which is the algorithm. Then also this area here, this is the entry points of my program to prompt the user to enter the size of the array and generates random array of that size. So we have the scanner, and it displays enter the size of an array. Then it um, it pass on to the scanner and go through the array container. So the user can choose three sorting algorithm, like I said, merge sort, quick sort, and heap sort. So now, as you can see here, I am creating my array in order to put all the necessary input of the user, whether if the user choose case 1, the function will automatically create a start time that I have created here, a local variable which is the start time and end time. So it depends on how the user wants or to wants and input of its choices. So here we have the this area, the function of this kind of method that generate random array. It is specify all the field with random integers between 0 to 9, and 0 to 1000, which is it doesn't overpass 1000, rather 999. So if um, the conditioning of this function is true, it returns the array, the value of an array. It turns out into generate random array, and then so on and so forth. So now we have the mid sort algorithm. So if the user choose the merge sort algorithm, this function recursively divides the array into two two half until the base case of an array size into one. So it reach merge it reach something like merge it reach something like 0 to 9, 999, because I put here 1000. So now the process of this one is I put the length of the array na sulod sa array in order to um, to read all the necessary inputs of the user, then followed by the function which I have made here to to this one, the merge. So this merge two sorted arrays from the left and right back until the original array. So it's sorted in order. So here, like, I am creating a value here of an I is equal to 0, then j is equal to 0, k is equal to 0. Then what I am doing here, like, creating while in order to loop and check whether it is the condition is whether it is true or false. So um, if my I is equal to 0, then it is lesser than to left, the length of the left order, and the j is right, and the length of the right. So if the left of the left if the left of I is greater than or equal to right, it resolve or it increment the k object. So it or one if the process go on until it's if the value of its variable is false, then automatically proceed to another implementation. So now let's proceed to quick static void. So this part here, which is the quick sort, that I put this in one of the um, is parameter int array and int low, and this is signature, which is all the necessary of um, nakalagay sa quick sort is mabutang niya makita niya diri sa iyang signature. So what I have done here is I have akong gibutang siya o if statement. If the low is mas gamay pa sa high, the partition will automatically making a score quick. So I have put here an array that low will increment 1. It means minusan nato ang pi nato o 1. So this function sort an array selecting a pivot and partitioning the array of two elements less than the greater than the pivot, and it then recursively done the pivot. So let's proceed to the another function or the field which I put in my code, the partition, in which this field, this function partition that arrays around the pivot returns the index of the after partitioning. So I have um, I created for loop in order to check whether the low object and the high object still remains, and if the conditioning still processing on, it will automatically increment each object, object j and um, object low and high. So j is representing here object of the low and high. So if the condition is true, it returns a value and plus 1. So now let's proceed to the swap method, which I indicate here that it helps the function to swap elements and indicates I and j array. Um, so array I is equal to array j, then array j is equal to temp. So in heap sort, this function first build a max heap in order to from the array, and then repeatedly extract the maximum elements of an array elements from the heap sort to the rebuild heap until the arrays is sorted. So the last part is the AB5. This function ensures the subtree rooted index and allows the array to satisfy the heap property. So the the what I have compared here is that the merge sort. Now let's see if I before that may I sample of how this for example. So sort sort naman I mean si heap sort okay heap sort. So what I have understand or observation of this the time has been taken. The merge sort it performs well on large data and it's good choice. So when stability is required. And how about the quick sort? So the quick sort, I guess it often faster and faster adder and algorithm which it has a better catch performance and lower constant factors. While heap sort is um, it has a good choice also for a large data sets. Also, in a memory usage is concerned, but generally slower than the quick sort due to more comparison. So that's all for this video. I hope you like my video and understand. So thank you so much.